Einstein said that the happiest thought of his life was imagining the implications and experience of a painter falling off a roof. He had that thought in 1907, just a couple years after he published Special Relativity. Special Relativity had established that the speed of light never changes, no matter who's looking at it or how fast they're moving. But Special Relativity wasn't exactly vibing with Newton's law of gravity, and it could only work when you took gravity out of the equation. So let's think about that painter falling off the roof. While he's in free fall, he doesn't feel gravity as he's accelerated towards the ground. He feels weightless. And if you let go of his paint can while he was falling towards Earth, the paint can would accelerate right on towards the Earth with him, and it would float beside him. So from his frame of reference, the can remains in a state of rest, and they float around together like there weren't no such thing as gravity. And that lack of gravity continues until the very moment he smashes into the ground. And his next thought experiment expanded on this notion of gravity and acceleration being indistinguishable. Imagine you're in an elevator without any windows and you're free falling in space. Anything that fell out of your pockets would be floating around alongside you, just like the painter's paint can. Or just like things floating around astronauts in the International Space Station. But then imagine there's a rope attached to the top of the elevator. And there's a super powerful being that can pull on the rope with a constantly accelerating force. The elevator would be pulled upwardly, and your feet and all that pocket schmutz floating around would land on the floor. And anything you picked up and dropped in the elevator would fall acceleratingly towards the floor, just like it would on Earth. In fact, there'd be no way for you to tell if you were in Earth's gravitational field or if there was a supernatural puller accelerating the elevator. And with that, he determined that acceleration and gravity are equivalent and called it the equivalence principle. Then he went on thinking about the equivalence principle and the implications and mathematics of it for 8 more years. Ultimately, it culminated in general relativity, which is the current description of gravity in modern physics with its 4-dimensional curved spacetime.